Welcome back. Okay, well, this video is about some electrical problems we had with the van and some electrical repairs that I carried out. Just want to put a disclaimer in here that I'm not an auto electrician. If you don't know what you're doing with your electrical repairs, watch some videos, research, and if you're still not sure, get some advice from a professional. So the problem is we've got a wire here, and this terminal's come off the end of it. Got these terminals off Amazon. I don't think they're particularly good quality, so I'm going to have to upgrade all these electrics and cables as we go forward. I think the big terminals are alright. Some of these smaller ones aren't up to the job. So this is the MPPT and DC charger. Taking inputs from the solar on these wires, so it comes in through this main solar switch into it, and the starter battery power cable comes through there through the switch into it. So at the minute we've got these lights, so it tells us that it's set up for lithium batteries. It's a blue light that shows it's connected to the batteries. Power Queen batteries we've got there. We've got two 100 amp hour Power Queen batteries, Life Pro, lithium, phosphor, all that sort of stuff. So when we switch the solar on, although there's not much light out there today, as you can see, we're hoping to get a light here to tell us that it's connected shortly. And there you go, that'll flash to say it's connected to that. Then we connect the alternators, a little picture of the alternator on it there. Be sure it's coming through from the front. It might not flash because the engine's not running, but when we go in the van we should be able to see that it's got a reading on the display that tells us everything's working. The display wire is one of these two here. There's one goes for a display and one goes onto the batteries. It's a temperature sensor. So this is what it's like when all the lights are on. So that one shows that we're working with lithium batteries, that's why it's blue. Different colours means different sorts of batteries. That one shows it's connected to the main batteries. This one shows the solar input. It should be on, but because we've started the van up and it's quite dull, it looks like the alternator is probably charging the batteries. This one here comes on when it's I think it flashes when this is charging it. And if it's stationary for a while with the engine off and the starter battery drops and the solar's on, the solar will actually charge the starter motor battery as well. So it does pretty well really. It's a bit dull today, so there's a good chance that the solar isn't able to cope with it. Just try and switch that off. So if I switch that off, right, yeah. There you go, so that shows that the solar has took over, but it's pretty dull out there today, like we said, so there's not much solar coming through there. So I'll switch the starter motor battery back on again. There you go. So it shows it's connected to the starter battery now. We're going to upgrade the supply wires from the battery to the DC to DC charger. The one out the DC charger, this one goes under here through this to charge the circuits. I may have to change those as well. So we're going to start by replacing the one that goes to the front, that one. That means all the circuit board's going to have to come off the wall, so we can get into the conduit that goes all the way at the front of the van. First thing I've done is switched it off. Next thing is to take off the full circuit board. So turn everything off. All the circuit breakers are off. The batteries are disconnected through this to this push bar. So that's safe to be disconnected now. Okay, so first thing, like I said, we'll disconnect the solar. Special tool for getting these out. Pushes in there, pulls them together while you pull those out. So that's the negative. The positive one can stay onto this bit, but it's going to have to come off there. So it's quite a sunny day today. I should imagine it'll be quite high. So that's giving us 19.5 volts. Not bad. It's a sunny day today. So after much tugging and pulling of that wire there, I haven't been able to shift it at all. So the next option is we're going to run some conduit through a hole there and run a wire down the inside the van instead of going behind all the panels where that bit of conduit went. But there you go. We've also got a spare wire in case we need one, I suppose.
I've taped it at that end.
What, so it won't come through anymore?
Yeah, hopefully it won't come through anymore.
Yeah.
Just don't tug at it.
We'll take it through that much.
Yeah.
Tape it to that tightly.
And then, would you tape?
Should be alright.
It's a bit better. I'm going to put it up there where you can see it. Put it on top of the fridge. Yeah.
We'll see what happens, eh?
Oh, very sharp that wire. Very sharp. I don't know if you can see it. Boo boo.
Right, do you want to pull or push? Oh, just a minute.
It's very sharp, this wire.
Are you ready?
I'm ready. I was born ready.
You pull, I'll push.
Right. I'll pull, you push. Push me, pull you. That was on Dr. Dolittle, wasn't it? Ah. Don't trust him near tin snips.
Alright.
Yeah.
Hold tight. Ow.
Ow.
So the first part of the job was putting a new terminal on the end of here. Got an 8mm hole, 25mm cable. On the end of it says 25/8. You have this set. Put it in the jaws. Alright, if it's a good connection you should be able to pull it really hard. If you're prepared to do that with your cables, then you've not got a good connection, so that's a good clamp all the way around it. No shrink sleeving left this size. There you go. Nice neat job. let's have a latest thing I'm going to do is get some lights up here so we can see what's happening. I can make some little angled blocks, put on here so the lights can be angled down slightly. So that's today's mission. Just clip it onto there. So, next thing is to the work. Let's go secure that wire. Swirl lights. So they can be directed down if you need them to. And that's the interior lights. So let's see what we're doing inside. The next thing I wanted to sort out was a problem on the inverter. We use a Renogy 2000 watt inverter. We've noticed that the inverter would drop out due to low voltage, so I've already replaced the supply wires. The cables Renogy supply aren't up to the task. After this, we were still suffering from low voltage at the inverter when we were using the air fryer, so I had to investigate this. Breaker of 13.3. So what I'm going to do is put full load that I've got on the inverter. Ooh. So that's the control switch there for the inverter, so it's turned on, it's got green on it. We've got a air fryer, so we're going to switch that on. 200 degrees. It's a air fryer that should take a maximum of 1400 watts. Just so I can put the maximum load I can on. I've also got an electric kettle plugged in. That's up to about 800 to 1000 watts, so altogether I've got 2300, 2200, something like that. It's a 2000 watt inverter. So now we've got got 11. It's going down to about 6 volts. I put the supply on the switch. That's staying still just under 12 volts. But the output on that circuit breaker is dropping down to 6. So I'm losing a lot across this breaker. So the breaker is up here. Can we see that? Okay. So now I'm going to see on this side of the breaker, the voltage is staying up there. It's dropping a fair bit. Output, when the inverter clicks off, it goes down to about 6 volts. I need about 10 half to 11. The inverter's just tripping out now, it's had enough. It's telling me it's overloading now. That noise. And it's showing a volt drop of about a fair bit across there. Goes up to 3 volts, which is massive on something like that. Okay, so now I've got just the air fryer on. Again, we'll look at what happens with this. Doesn't like that at all. Again, 12 volts on the supply side, because not doing anything, it's dropping down quite rapidly. It gets to the point where it cuts out because it needs that good supply, but the supply voltage to the breaker stays constant. So this is a faulty component here. It's a cheap, it's the one we got off Amazon. It's supposed to be rated to take up to 300 amps. The inverter needs at least 200 to run. Well, actually, we'll use Watt's law, and it turns out it needs 166, 167 amps to operate at 2000 watts. So this is faulty. It's also getting quite warm. So I'm going to replace this with a fuse, and we'll test it when it's got a fuse in it and see what it does. Okay, switch it off for now. So it's saying I don't want to work anymore. Scream. So same experiment as did before, except now I've replaced the breaker that was over there with the fuse. I've fitted here just for the where the lines go, and now we've got 11.38. We've got the air fryer and the kettle on, so it's over 2000 watts it's drawing. .68 again there. Volt drop of 0.25 volts across that, but it's drawing a big current of probably 170, 180 amps, something like that. Could work it out using Ohm's law. I'll knock the kettle off. So now there's just the air fryer on. The air fryer it's got us over 12 volts now, so it's well able to deliver the sort of current we need. And it says no volt drop across it. Put it down to that. Should have very little volt drop anyway. Like 1, 2. Like I say, it's drawing a big current to operate what it's doing, so that's okay. Right, so just before I close this video out, I thought I might go through some of the setup we've got here and why we've done it really. I try to keep the setup as simple as possible, so I haven't gone for loads of different components. It's all Renogy stuff that we've used, and I'll just show you what we've got and why we've got it. The power side of stuff, the house batteries are 2 Power Queen 12 volt 100 amp hour batteries, so that should give us 200 amp hours of power to supply everything. The other output from the battery comes through to a 2000 watt Renogy inverter. The power from that goes to a consumer unit. It's just a 3-pin plug at the back. There's another 3-pin outlet at the back as well, so I can plug an extension in that if I want to. We worked out all our usage. We thought 2000 watts would cover what we need. Since we did our setup, battery technology's changed, and you can get bigger batteries giving you up to like 400 amp hours for one battery. So to do it again, I'd probably go for a 3000 watt inverter, but then you'd need bigger supply wires and everything, so you'd have to consider that. This powers up this consumer unit, which has all the trips and stuff inside that we need, and that's fine for what we're doing. That goes to inside the van that powers all the AC systems. Charging side, I try to keep it simple again. We've got 3 175 watt solar panels on the roof. They come through a switch to this unit. Again, keeping things simple, I've gone for a Renogy 50 amp DC to DC charger and MPPT controller. So that's what that does. It takes solar, it takes charge from the starter motor battery in the van. If you ever do any of these and you're using this system, you've got to be aware of how much voltage is coming through from the solar panels. I've had to wire my solar panels up in parallel because these will only take 25 volts maximum, and with the 3 solar panels I have on the top, it would have given me something like getting to 60 volts, and that would have overdone it. Wiring them in parallel means that I got a maximum voltage of 20 volts and a current output of between up to about 14. Oh, sorry. A current output of just over 25 amps. That's plenty for what we do. With the setup as it is, when you wire them in parallel, it means that if you have one panel that's slightly obscured by cloud or stuff like that, you still get output from the solar panels. If you have them wired up in series, you sometimes find if it's a bit of a cloudy day or one of the panels are obscured, it drops the output considerably. So you've got to bear that in mind. Again, to keep things simple, I don't have anything connected on Bluetooth. I don't want to monitor my phone all the time to see what the charging's doing, how much I've got left and things like that. On this control panel here, we've got the main switchboard. That works the lights inside the van. They are the water pumps, and that's the water heater, which I'll talk about another time. That's the remote control for the inverter. So you switch it on, and the AC power supply is on, switch it off and it goes off. Quite important to have it switched off, because even when it's not being used, if it's turned on, the inverter draws about 1.5 amps. So over time that can build up. We've also got this, and this gives us the information about what the batteries are doing. Well, that's it for now. Thanks for joining me. I hope it's been helpful to some people, and it shows you a bit about some diagnosing things. If it's any help at all, let me know in the comments. If you want any more information about the setup, why we've done things, what we've got, then please get in touch. Leave a comment in the comment section, and we'll look forward to seeing you again next time. Bye.